What's up, everyone? This is my second assembly language tutorial for you all. Thank you for watching my first assembly language tutorial and motivating me to continue making more of such videos. In this tutorial, I'm just going to be talking about our first experiment, which is to display hello using a set of debug commands, if I'm not wrong. It's a very easy experiment. I'm quite sure most of you all have already understood it, but still I'm gonna go ahead and make this for those who have no clue how stuff works in assembly. So let's get started. Go ahead, open up command line on your PC. Now if you're running Windows 7, any version of Windows 7, I'm quite sure that when you try to run debug for the first time, you're gonna get this error. And what this error really means is that debug.exe is not present in C users XYZ. So either you have to go to the location where debug is stored and run debug from there, or you can just set the path to that location and run debug from anywhere. So I'm just going to go ahead and I'm gonna go to that location where debug is stored and run debug from there. So the location really is cd windows cd system 32. Yeah, this is the location where debug.exe is stored on your machine. So go ahead and type debug.exe. Now that's debug started, but we need to write some code. So we need to enter the assembler in debug. So what we write is a, which is the command to enter assembler in debug. So after you enter A, you see this weird number on your screen. What does that number really mean? Well, that number obviously represents an address in the CPU memory, which is the internal memory of the CPU. Now the 13A3 changes with whatever machine you're using and how data is organized on that machine. But the 0100, which you see right here, would be same for any machine you use in any operating system you work on. That's because 0100 is the standard starting address for machine code. So that's just going to be the same. If it's not, you probably have something wrong with your PC. So now we need to write a program which prints hello on this console. Let's just jump off to Notepad. Yeah. Now we need to print hello on the screen. So to print hello on the screen, let's just forget assembly for a minute and let's just assume we're using Java or C or any other high-level programming languages. What steps do we really need in order to print something on the screen? We obviously need to know the function. That displays something on the console. And what we need to do is to pass the string we need to print to that function. So I believe this is the easiest program because yeah, that's all you need to do. The function that displays something on the console, and we need to pass the string we need to print to that function. So if you all have seen my previous tutorial on assembly, I had mentioned there that in DOS we do not have names for functions. What we have are function codes, which are hex numbers. So the hex value for the function that prints a string on the screen in DOS is 09H. Now 09H is the hex value of the function that prints a string on the console. Remember that, a string, not a character. This is only for a string. So we're going to need this function find, and we're going to have to pass our string to this function. Now, how exactly do we do that in DOS? So to pass the string we don't need to define any variable. Obviously we can define a variable and use that, but what we really need to do is to store our string in the dx register. Now what the dx register really is, it's your data register, right? So whenever you call a function in DOS that has anything to do with data you need to print, data you need to manipulate, anything, every function in DOS will check the value in the dx register. So for example, we need to print something on the screen. Alright, I call the 09 function, which is for printing something on the screen. So what to print? It'll go directly to dx and we'll see the value there. So whatever it finds in dx, it'll print that. As simple as that. There's nothing else to it. So store your string in dx, call the function to display that string, and that's it. Now let's get back to our debug and start writing the code here. So first of all, what I'm going to really do is I'm going to move ah09. Now people ask why use ah is our basic command register in DOS. So whenever I have to execute a function in DOS, I'm going to move the function code to ah register. This is something really basic. So and it does not change. It's always going to be ah where we move our command values. So move ah09, fine. I'm calling the print string function. Done. Now what to print? Print the value in dx. Now we haven't defined our string as of now, so we don't know where what to store in dx, and we cannot write something like dx and hello world, because this would be wrong. This is just wrong. You cannot do this in assembly. So what you need to do is for now I don't know what I'm going to be moving in dx. So what I'll do is I'll just write move dx comma o10 a, let's say. So what that really means is the value which is stored in o10a is going to be moved into dx. Now we haven't stored our string, but now we know that since dx will have the value at o10a, we will define our string at o10a. So we'll just execute this, and next thing you write is the interrupt. Now what does int21h really do? Int21h is an interrupt to signal the processor that okay, stop doing whatever you're doing and execute the statements above this line. So int21h will interrupt the processor and it will execute statements starting from O100 to O102. Alright, and after this we just write an int20h. Now int20h is to exit our program. So for successful execution we should write int20h, because there are chances that you might enter sort of an infinite loop if you do not write int20h to end your programs. There is an alternative to this, to int20h. I will talk about that later, but for now I'll just end my program with int20h. Fine, this is done. Now we need to define our string at o10a. We haven't done that. So how to do that? This is o109, but I need to go to o10a. So what I'll do is I'll just exit this and I'll write o10a, and this will take me to the o10a location in the memory. As you can see, the address here now is o10a. Now this is a very cool feature in DOS. Actually, if I made a mistake at let's say o102, I can just go to o102 and edit it. Just write a space o102. I'll take you to the o102 line. Whatever you write there would be stored at o102. The previous value of instruction at o102 would be erased. So yeah, that said, let's define our string. Very important. We just write hello world. Now db is represents defined byte in DOS. So what I'm really doing here is defining a series of bytes starting from 010A, and it's like an array of bytes, and it's just going to be having hello world as its value. So define byte hello world is storing the values HELLO space world starting from 010A. So it'll be 010A, 010B, and so on. Now, if you notice, I've entered a dollar sign here in the end, and that is the string terminator character in DOS. Why do you need the string terminator character? If I don't enter the dollar here, this function, the AH09 function, will never end because it will never know where the string ends. Alright, so I need to tell DOS that okay, my string ends here with the dollar sign. If I don't write the dollar sign, your screen is going to be filled with a bunch of junk characters which follow the string, or the values which follow the memory location where this ends. So the dollar here is a must if you want the output to be displayed correctly. So now as you can see, I defined my function, I moved the value 010A to dx, and I have defined my string at 010A, and I have successfully closed my program. So well, I'm done here, right? So what I'm really going to do now is try to execute this. And how do you execute this program? You use the G command in DOS. The G command represents go in DOS, and what go does, it assembles your code and executes it. Now how you really write that is G is equal to some address. Now if you don't enter an address and just write G, it's going to start executing your program from 0100, which is the default. But if let's say I want it to start executing my program from 0105, so I write G is equal to 0105. Alright, and this would mean that I want the execution to start from 0105. Well, in this case I just want the execution to start from 0100, so I'll just write G and enter, and you see hello world, and your program terminated successfully. So let's go back and just review this one more time. Move AH09. 09 represents the print string function, very important. It represents the print string function. Okay, fine. I moved 09 to AH, print string function loaded. It's asking what to print. Alright, I'll print the value in DX. What's in DX? 010A. 010A, alright, what's that 010A? Hello world. Why the string terminator character? We don't want junk on our screen, so that's why the string terminator character, followed by an in21h. In21h, very important. Interrupt the processor and execute these statements from 0100 to 0105. In20, exit the program. Yes, in20 is to exit the program and get back to the debug.exe console. Now, one very important thing I need to tell you all here. When you write code in debug, the execution is unidirectional. So what I really mean is, if G starts from 0100, it will not go to a previous memory location. What I really mean here is, let's say I had written this. Let's say the location was 0100, and I wrote move AH09. Now let's say I define my bytes here, db hello world, and so if I did this, and at 0102, by default an instruction in DOS takes 2 bytes, so 0100 to 0100 to 0102, sorry about that. So here if I wrote move AH, 09, and at 0105 whatever, if I wrote int 21h, and followed by an n20h, and I try to execute this would not run properly. Now, oh, did I forget the dx? Yeah, I forgot the dx, I believe. So let's make this 70105 and write my move dx comma 100. So this will not work properly. Why would this not work properly? Because when I type G, it starts executing my program from 0100, and when it comes to 0105, it sees that okay, fine, I have to move to dx the value stored in 0100. Now, for that, it has to go back, right? It's at 0105, it has to go back to 0100, read the value there, and store it to dx. And this is a limitation because it won't be able to do it. So when I run this program, I'm just gonna get a blank line, and program terminated successfully. So you're just going to wonder that where did your hello world go, and even though you've defined it properly, everything is just fine, your program doesn't work. And why it doesn't work is because it cannot go back and read the value at 0100 and store it to dx. So remember that whenever you're writing code in debug, your data should always follow your code, because if it is before your code, the assembler won't be able to go back and read your data. So yep, that's it for the hello world program. If you have any doubts, if something is not working, you can comment on this video. And yeah, that's it. I'll see you all next time. Have fun.